Hello everyone, today my team and I will be making a presentation on the topic application of differentiation. So first of all, I'd like to thank our lecturer for giving us the opportunity to make this presentation. So first, let's start with the group members introduction.
Hey everyone, my name is DUVENTHIREN, son of Lakshma Yogendran, and my registration number is 01 DKM20F1065, and I'm from DKM2B. And yeah, here this is my picture, this is how do I look. Next, my friends will be introducing themselves.
Hello Madam Lim, I am LISHVAARAJ Naidu Analaki Sivaji Selvan. This is how I look. My registration number is 01DKM20F1066, and as you know, my class is DKM2B. Thank you, Madam.
Hello guys, my name is INESH, son of Ravi. My registration number is 01 DKM 20F1041. I'm from class DKM2B as well, and this is a picture of me which you guys can see. Okay guys, so let's start with the introduction to our topic for today. Differentiation is a technique which can be used for analyzing the way in which functions change. In particular, it measures how rapidly a function is changing at any point. In engineering applications, the function may, for example, represent the magnetic field strength of a motor, the voltage across a capacitor, the temperature of a chemical mix, and it is often important to know how quickly these quantities change.
Okay, now it's me again guys, DUVENTHIREN. Now I'm going to solve question 8. Now let's get into the question. The question is, find the coordinate of the stationary points of y equals to x squared minus 2x plus 3. Now let's solve it. Okay, now the first step will be finding dy dx. As the equation is y equals to x squared plus 2x plus 3, now we have to differentiate them by taking the power from every unknown and times it with the value which is in front of the unknown, and have to add -1 to the power after we times it with the value at the front of the unknown. So now, once the differentiation is done, the value will be 2x plus 2. So it is dy dx is equals to 2x plus 2. As we all know that at stationary point dy dx is equals to 0, so 2x plus 2 is also equals to 0. Now we have to find the value of x. As the equation is 2x plus 2, the x will be equals to -1. Now we have successfully found the value of x. Now we can get into the step 2. Okay guys, now step 2 will be substituting the x value into the equation. If x equals to -1, then substitute the x into -1. So now all the x will be -1. As you all can see, x squared has become -1 square and 2x has become 2 in bracket -1. This is what it is. Now we can solve the equation as everything is in whole number. Once solved, we will get y equals to 2. Now we have also found the value of y successfully, as the value of x is equals to -1 and the value of y is equals to 2, so the stationary point will be -1, 2. This is its final answer. Thank you for being all ears, guys. And now LISHVAARAJ will explain question B.
Thank you, Devendran, for presenting question A. Now I am LISHVAARAJ going to present about question B. In question B, we are going to find out the coordinates of the stationary points of y equals to x power 3 minus 3 over 2 x power 2 minus 6x plus 10. Then we are going to determine their nature and sketch the graph of the curve. Now let's fly into the step 1. Okay, let's see the step 1 for question B. Step 1 is we need to find dy dx. What do we mean by dy dx? Dy dx means we have to differentiate an equation given. Here the equation given is y equals to x power 3 minus 3 over 2 x power 2 minus 6x plus 10. As we get this equation, we need to differentiate them by take the power of every x times with the value in front of x like this, then minus the power with 1. So we will get another equation for dy dx, which is dy dx equals to 3x square minus 3x minus 6. As we all know, at stationary point dy dx equals to 0. So we must take the equation for dy dx, which is 3x square minus 3x minus 6 equals to 0, like this. Then we need to calculate the value for x. As we can see, this is the calculations, and we will gain two value for x, which is x equals to 2 and x equals to negative 1. The second step of question B is we need to substitute the x value into the equation. Since we get two x values from step 1 for question B, which is x is equals to 2 and x is equals to negative 1, we will take the first value, which is x is equals to 2, and put them into the equation. By calculating the equation which is substitute with 2, we will get the value of y, which is equals to 0. Then we will use the second value of x, which is x is equals to negative 1, and substitute them into the equation. We will get a value of y is equals to 27 over 2, or we can even say that as 13.5. From this we know that when x is equals to 2, y will be 0. When x is equals to negative 1, y will be 27 over 2. The stationary points are 2, 0 and negative 1, 27 over 2. Let's go to the third step of question B. The step 3 in this question is to find the d square y over dx square. What is d square y over dx square? It means we need to differentiate an equation twice. Why do we do that? To find the maximum point and minimum point of the equation. As we already differentiate the first equation once in step 1, we know that dy dx equals to 3x square minus 3x minus 6. So we need to differentiate this again, and we will get another equation, which is d square y over dx square equals to 6x minus 3. As we already know the x values, which is 2 and negative 1, so now we need to substitute these values in the equation we differentiated for the second time. So when x is equals to 2, we will get a value of positive 9, and when x is equals to negative 1, we will get a value of negative 9. As x equals to 2, get a positive value 9, which is more than 0. This means it is a minimum point. And as x negative 1 gets a negative value which is less than 0, this means it's a maximum point. So now we can conclude that 2, 0 is the minimum point and negative 1, 27 over 2 is the maximum point. Now we have reached to the final part of this question, which is sketching the graph. This graph is also known as graph of the curve. This is the graph. From this equation given, we have done all 3 steps from 1 to 3 and we have gained certain things like the coordinates, the maximum point and the minimum point. By gaining this, we have get the perfect curve and this turns out to be a good graph. So now I have done my part of presenting the question B. I will hand over to INESH to finish this presentation well. Thank you, teacher.
Okay, so thank you to Duveen and Lishva for explaining those questions clearly and detailedly. Hope you guys understood it well. Now we have reached the conclusion part of the presentation. Here we'll be looking at different applications of differentiations. First is the rate of change of a quantity. Second, increasing and decreasing functions. We can also use it for tangent and normal to a curve, minimum and maximum values, Newton's method, and lastly, it can be used in linear approximations. Alright guys, so that's our presentation for the topic applications of differentiations. All of the credits goes to my team members and myself, and also our lecturer for engineering mathematics, who is Puan Lim Yong Chong. Thank you guys.